Hello, welcome to Machine Learning Foundations for Product Managers. This is my Coursera course project. My name is Kavita Ryali. Starting with the problem statement, we want to build a model to predict the electrical energy output of a combined cycle power plant. Total number of observations were 9,568 of the environmental readings gained from the sensors in the plant. And the following are the columns that were available in terms of the data and all the variables. The last one is the target, and so we have all the variables there. Machine learning approach that I used and why. Supervised learning would be the best choice, I think, in terms of the machine learning approach. Reasons listed below. There were past observations available to train the model. And also I see a linear relationship between the available features and targets. Conclusion is that it is a regression problem since it is a numerical target value that we are looking to predict. Few features observed, hence no need for hyperparameters. The test approach was 10% dataset for model testing, 10% for model evaluation, and 80% for model training. Algorithm features and details, I'll be using two different models and going with a parametric algorithm, and it is based on multiple linear regression. Model 1 would include 3 out of the 4 features, and model 2 would use all the features that are available. The assumption is both models will be trained using the same data. The model validation will be done using the R-square methodology, and the best performing model will be the final choice. Model performance will be done using the mean square error as an output metric, and that will also provide us the details. So let's move on to the analysis. This is my analysis tab, and the first 5 columns are the dataset as available. Column E is the output, and column F and G are the ones that provide the Y value for the 2 models. This is the legend. The trial data set is yellow in color, it's 80%. The evaluation data set is blue in color, it's 10%, and test data set is green, and it's 10%. So the step 1 was to do the regression analysis on the trial data set for both model 1 and model 2. As you can see, I'm using Excel spreadsheet and using the data analysis feature to do these calculations. So for model 1, we are getting these results, and these are the coefficients for the 3 variables used, and also the R-square is 0.91. For model 2, where all the 4 variables were used, we had these coefficients, and the R-square value is 0.92, so it's pretty good. It has to be in the range of 0 and 1. So the next step was to calculate the Y for both model 1 and model 2 based on the coefficients that we got in the in step 1, and use this formula, and that's how I got the model 1 column F was populated, and model 2 column G was populated for the entire trial data set. Moving on to the next step, which was done on the evaluation data set to look at the R-square value. This is to look at the how best we can validate and choose the right model. So this was the R-square formula that I was using, and for both model 1 and model 2, these were the R-square values, pretty good again, 0.95 for model 1 and 0.96 for model 2. I populated the eval data set accordingly. So again, that is kind of the results. And step 4 was again done on the test data set to calculate the mean squared error. This was the formula that was used, and the results were that for model 1 I got 23.69 versus for model 2 I got 20.15. So the choice was to go with model 2. So let's look at the the evaluation data set. Um, so this is how I populated the the R square value for both model 1 and model 2. And let's go back to the step 4 where I explained this was how I calculated the mean squared error. So let's go to the actual data set, which is the test data set. And this is my test data set, and these were the two values that I got. So so that was kind of my analysis, and final choice was to go with model 2. Thank you.